We're going to use the idea of squares to measure a line segment. So remember, if we have a square, the length of its sides is the square root of its area. So here we have an example where we want to find the length of line segment PQ. Well, it's not vertical or horizontal, so it's not like I can just count the number of squares. So that doesn't work. So there's two different ways we can do it. We can add areas or we can subtract areas. I see that this got a little messed up. Method 2 should be over here. We're going to do method 1 on this side, so we're going to add areas on the left here. So if we look, we've made a square, measured off right angles, and we made a square from PQ going up. So what I'm going to do is I'm going to draw some dotted lines, and then you can see I have a square in the middle here. So I've got a square, and now I've also got, I'll draw them solid, I've got 4 triangles. So the square in the middle, pretty easy, it's a 2 by 2, so the square is 4 square units. And then I have to look at each triangle. So if you remember, the area of a triangle is the base times the height divided by 2. So the base, and all 4 of these triangles are going to be identical. So if I look at the base, and this one, for example, RS, whatever that point would be, 1, 2, 3, 4, the base is 4, the height is 2, and I divided by 2, so 4 times 2 is 8, divided by 2 is 4, or I'm multiplying divided by the same number, it's going to go back to 4. So each triangle has an area of 4. Well, there's 4 triangles, so 4 triangles. So it's 4 times 4, so that's 16. So we got 16 plus 4, because we got the area in the middle, and those 4, so 16 plus 4 is going to be 20 square units. So the length of PQ is the square root of the area. This is the total area. So the length is going to be the square root of 20. 20 is not a perfect square, and so we can't find the exact number, so we're just going to leave it as a square root of 20. We can also subtract areas. Same idea, except for now we're going to make a big square that's all the way around. We're going to find the area of the square. This is the big square. And I go 1, 2, 3, 4, 5, 6, and this better be 6. 1, 2, 3, 4, 5, 6. That's awesome. So 6 times 6 is 36. You would find the triangles here. You can see the triangles are exactly the same. We've got 4 triangles. And they are 1, 2, 3, 4 by 2, which is 8. 4 by 2 divided by 2, which is 8 divided by 2, which is 4. And the area of 4 triangles, which apparently I have a hard time writing, triangles, 3 angles, is 4 times 4, which is 16, just like we had before, but now we're going to subtract that area. So 36 minus 16, and oh look, awesome, the area is still 20. So that's the area. The length is going to be the square root of 20. So we know the length of PQ is the square root of 20 with either method. You're welcome to use either one. And again, if those aren't making sense to you, make sure you're asking and I will help you with that. So is the area of every square a perfect square? Well, we just looked at a square that RSPQ, PQRS, whatever you want to call it, is clearly a square, but its area isn't a perfect square, so no. When will the length of a square not be a whole number? And it will be exactly then when the area is not a perfect square. So if we tried to take the square root of 20, you would get 4.5-ish. So we know that the length of one of those sides is around 4.5, but it's not going to be exactly 4. That is all we have for that. So there's your practice along with an extra challenge.